In this problem, 3 circles has been given and these circles are touching to each other at various points. So this is one point of contact, this is another point of contact, and this one is another point of contact. The radius of largest circle is 4 unit, second largest circle radius is 2 unit. Then we have to find radius of a smallest circle. That is, what is the radius of this circle? And this line is tangent line. This is tangent to all the circles. So tangent to this, and tangent to this. And this is the point of contact where circle and tangent are meeting. Similarly, this is another point of contact, and for this circle, this is point of contact. Now to solve this problem, I will do some construction and I will use Pythagoras theorem. So let us first draw perpendiculars, perpendicular PB and perpendicular MC. So from point P, I will draw a perpendicular on this line. And similarly from point M, let us draw a perpendicular again on this tangent line. So these two are perpendiculars. Now this is radius and this is tangent and this is perpendicular. This means this will pass through the point of contact. So tangent and radius are perpendicular, and in this case by construction this is perpendicular. This means this is point of contact. This is also point of contact. Now let us draw another perpendicular from point P on this line, that is MC line. So this angle is 90 degree from construction. This is 90 because this is radius and this is tangent. This angle is 90 because this is radius and this is tangent, and this 90 because of construction. This means this angle is also 90 because for any quadrilateral, sum of angles is equals to 360 degree. This means this is a rectangle. So now I can say BPDC, that is this one, is a rectangle. Now let us say radius of a smallest circle is r, a small r. And since this is a rectangle, this side is equals to this side. In a rectangle, opposite sides are equal. So BP is equals to CD and both are equal to radius. Now let us say this distance is x, BC is x. So this will also be equal to x because these are opposite sides of rectangle. So BC equals to PD is equals to x. Now let us join point P and point M. So this is another line, MP. Now if you consider this triangle, that is triangle PMB, PMD. This is a right angle triangle because this angle is 90 degree from construction. So I can use Pythagoras theorem. So to calculate Pythagoras theorem, I need this distance and this distance and this distance. So let us calculate MD. This total distance is 4 and this distance is R. So this distance is 4 minus R. So MD is equals to 4 minus R. Now what about this distance? This line will pass through the point of contact. Why? Because if you consider a common tangent and if you draw a perpendicular, this will pass through the center. Similarly this side. If you draw a perpendicular on this common tangent, this will pass through the center. So point of contact and point P and point M all lie on the same line. This means now I can write PM is equals to this radius plus this radius. This radius is R and this radius is 4. So this is 4 plus R. So MP is equals to 4 plus R. Now let us use Pythagoras theorem in this triangle. So I can write MP square equals to PD square plus MD square. Now MP is 4 plus R. So let us plug the value. MP is 4 plus R. PD, we have assumed that this distance and this distance which is equals to x. So this is x square. MD square, MD is 4 minus R whole square. So now I can simplify this. This is nothing but a plus b whole square, that is a square plus b square plus 2ab. And this is a minus b whole square, that is a square plus b square minus 2ab. So if I use this formula, I can write a square, that is 4 square is 16 r square plus 2ab. So 2 times 4 is 8 times r, that is 8r. This is x square and this is 4 square plus r square minus 2ab. So 4 into 2, 8. This is minus 8r. Now I can cancel 16 and I can also cancel r square. And if I take this 8r to the left hand side, so this is plus and this will also become plus. So this is 16r. So now I have x square equals to 16r. And if I take a square root both sides, this will be x is equals to 4 root r. So basically now I know this distance BC or PD which is equals to x in terms of radius of a smallest circle. Now I can repeat the same steps for this and this circle. We have done steps for this one circle, the bigger circle, and this circle. Now I will do the same steps for this circle and this circle. This means let us draw perpendiculars from N and from point P. So I can draw perpendicular NA and perpendicular PB. Now once again from point P, I will draw perpendicular on NA. Now this is 90, this is 90, this is 90. So this has to be 90. This means this is a rectangle. This means this distance is R. So this distance is also equal to R. So AEPB is a rectangle and in this case distance EA or AE is equals to BP which is equals to a small radius R. Now let us say this distance is equals to by, that is AB, and AB is also equals to EP because this is a rectangle. Opposite sides of a rectangles are equal. So AB is equals to EP is equals to by. So this distance is by and this distance is by. Now let us connect point N and point P. So these are two centers. Now I can calculate distance NP. So this is NP. This distance is, this is radius and this is another radius. So this is 2 unit and this is R. So this is 2 plus R. Same logic that this point will fall on this line because this is a point of contact. If you consider a tangent, perpendicular has to pass through this center and it also has to pass through point P, that is center of another circle. So NP is equals to radius of this circle plus radius of this circle, and radius of this circle is 2 unit and radius of this circle is R unit. So this is 2 plus R. NE, this total is 2 unit and this is R unit. So this is 2 minus R unit. So this is 2 minus R. So now I can apply Pythagoras theorem in this triangle because this is also a right angle triangle. This angle is 90 degree from construction. So hypotenuse square, that is NP square, is equals to sum of sides, a square of sides, that is NE square plus PE square. Now we can plug the values. NP is 2 plus R. NE is 2 minus R. And we have assumed that this distance is equals to by, that is PE is equals to by. Now again I can expand this. This is A plus B whole square, that is A square plus B square plus 2AB. This is A minus B whole square, so A square plus B square minus 2AB plus by square. Now R square this side will cancel. Similarly 4 and 4 will cancel. So let us cancel 4 and 4. Cancel R square and R square. So what is left? Minus 4R and this side plus 4R. So if you take minus 4r this side, this will become 8r. So I will have by a square equals to 8r. This means by is equals to 2 root 2r. So this is my equation 2. So we have found distance x, that is from point of contact of this circle to point of contact of this circle in terms of a small r. And by distance, that is point of contact of this circle to point of contact of this circle in terms of r. So I know x in terms of r and I know by in terms of r. But we have to find r. So I have to relate x by and a small r. For this purpose, let us draw Fm, Fn and Nm. This is the topmost point of this circle. And this diameter of this circle is 4 unit, which is equal to radius of this circle. This is equals to 4 unit. This means from top point, if you connect this center, this will be a tangent line. And this is radius. So this means these two are perpendicular. So this is a right angle triangle where Nm is the hypotenuse. Now what are distances? Fn distance is the radius of this circle, which is equals to 2 unit. What is Fm? This Fm total is, you can say from here to, so from here to here and then from here to here. That is, this distance is y and this distance is x. So this is x plus y. And Nm, this distance. This is radius of this circle plus radius of this circle. So this is 2 and this is 4. So that is 2 plus 4, which is equals to 6. Because this is point of contact and this line will pass through the point of contact. So this length is equals to radius of this circle plus radius of this circle. Now this is a right angle triangle. I can use Pythagoras theorem. So if I use Pythagoras theorem, hypotenuse square, that is Nm square, equals to sum of squares of side, that is Nf square plus Fm square. Nm is 6 unit, so let us plug all this value. Nf is 2 unit, so this Nf is 2 unit. So this is 2 square, Nf is same as Fn, so this is 2 square. And Fm is x plus y, so this is x plus y whole square. And now I can expand x plus y whole square is equals to x square plus y square plus 2xy. So 6 square is 36, 2 square is 4 and this is x square plus y square plus 2xy. So now I can take this side. So this will become 32. So x square plus y square plus 2xy is equals to 32. Now we can plug the value of x and y. So x is equals to 4 root r, this is equation 1, and y is equals to 2 root 2r, that is equation 2. So let us plug the value of x and y in this equation itself. So if I do that, so this will remain same and x square will be 16r and y square will be 8r. And this is 2xy is 4 into 2, 8. And this is 2, 8 into 2, 16. And this is root 2 and root r into root r, basically r. So if you simplify, this side goes, so this will 36 minus 4, that is 32. And this will be 16 plus 8, that is 24. And this is 16 root 2 r. So r I have taken common. So from here, r is equals to, basically I can cancel 8. So 8 4 is 32 and 8 I can cancel here also. So 8 into 3, which is 24, and 8 into 2, that is 16. So 2 root 2r. So from here I can write r is equals to 4 divided by this number, that is 3 plus 2 root 2. So I hope you enjoyed this problem, and if you like these problems, please share with your friends, like this video and subscribe to my channel. I will see you in the next video. Thank you.